Hello, welcome to Chapter 4.2, Solving Quadratic Equations. Solving quadratic equations by factoring. The multiplication property of 0. Let a and b be real numbers. If a times b is equal to 0, then either a is equal to 0 or b is equal to 0, or both a and b must be 0. Solving quadratic equations by factoring. 1. Make sure the equation is written in standard form and that it is set equal to 0. 2. Factor the left-hand side of the equation. 3. Set each factor equal to 0 and solve for the variable. In example number 1, we're asked to solve x plus 3 times 2x minus 1 is equal to 0. So let us go over to the whiteboard and see how this is done. In our first example here, we're going to solve x plus 3, 2x minus 1 is equal to 0. Now remember what we said on the PowerPoint about when we're solving something. So here, as you see, something is equal to 0. That means each of these factors we're going to set equal to 0. So we have x plus 3, and we have equal to 0, and we have 2x minus 1 equal to 0. So I'll just take this out of the brackets and make it into just a simple algebraic equation. And similarly, I'll do it for this factor too, and make it into a simple algebraic equation. So we end up with x is equal to negative 3. And in this one, we have 2x is equal to 1. Divide by 2, divide by 2. So x is equal to 1/2. Note that we have 2 answers because this was factored from a quadratic equation, which means that we have 2 solutions. Reviewing what we did on the whiteboard, in this first example, the equation is already factored and it is already set equal to 0. To solve, we simply set the individual factors equal to 0. So each individual factor, the first one is x plus 3, and the other one is 2x minus 1, and we set each of these equal to 0. And we solve, and we find the first one, x is equal to negative 3, and the second one, x is equal to 1/2. The solutions are negative 3 and 1/2. And notice how I put the curly brackets to represent that it is a set. In example number 2, we're asked to solve 3y minus 5 times 2y plus 7 is equal to 0. So here we're going to go to the whiteboard and show how we solve for y. Similarly for example number 2. So let's look at example number 2. We have 3y minus 5 times 2y plus 7 is equal to 0. So again, we have 2 factors, and that which would form a quadratic equation. So we're going to assume we have 2 solutions. So I'll drop the brackets and I'll set each one equal to 0. 3y minus 5 is equal to 0. And the other one is 2y plus 7 is equal to 0. So now I'll solve for the first one here. 3y is equal to 5. Divide by 3. Divide by 3. So y is equal to 5/3. Now, the other one, we have 7 minus 7 And we do the same thing. 2y is equal to negative 7. Divide by 2. Divide by 2. And y is equal to negative 7 over 2. Now, some students would be really upset seeing that the answer is a fraction. But I have to tell you, fractions do happen. And sometimes you will have answers that are fractions. So this particular one happens to have two answers that are fractions. In reviewing what we just did on the whiteboard, we set the two factors equal to 0, 3y minus 5 equal to 0, and 2y plus 7 equal to 0. Then we solved for each of these factors and found y is equal to 5 over 3, or y can be equal to negative 7 over 2. In example number 3, we're asked to solve for 9x squared minus 4 is equal to 0. So let us go over to the whiteboard and work this out in detail. In example number 3, we're asked to solve 9x squared minus 4 is equal to 0. Now, in our previous problems, everything was factored for us, because in order to solve it, we have to break it into its factors and set each of those factors equal to 0. Well, in this one, we notice we have a familiar pattern, and we see we have the difference of two squares. 9 is a square, x squared, and 4 is a square. So we could factor that in the following way based on a trick we learned earlier. So we can say 3x plus 2, and that this factors to 3x minus 2, and it's equal to 0. Then we set each of these factors equal to 0 as before. And we solve each of these in a usual algebraic way. And then the other one. Two over 3, and here we have x is equal to negative 2 over 3. So here are two answers. One of them is negative 2 over 3, and the other one is positive 2 over 3. Reviewing what we just did on the whiteboard, in this example, you must factor the equation. Notice the familiar pattern, the difference of two squares. After factoring, set the individual factors equal to 0 as before. And we do this, and we find that x is equal to negative 2 over 3, or x is equal to 2 over 3. In example number 4, we're asked to solve 4c squared is equal to 25. So let us go over to the whiteboard and work this one out. We have 4c squared is equal to 25. We don't have it in standard form. And standard form means we have to have the equation equal to 0. Remember, ax squared plus b plus or minus bx plus or minus c is equal to 0 is called standard form. So what we have to do is we have to now move the 25 to the other side and set it equal to 0. So here we will do that. And notice we have a familiar thing going on. And again, we have the difference of two squares. So we have 4 is a square, c squared minus 25 separated by a negative sign. So now we can use our little trick for the difference of two squares and write 2c minus 5 times 2c plus 5 is equal to 0. Now, it doesn't matter which side I put, whether I put the plus here or the negative here, so long as I have them both, because remember, that's the central term that'll cancel out. So as before, I'll set them equal to 0. 2c minus 5 is equal to 0, and 2c plus 5 is equal to 0. And I will solve for 0 for both of them. 2c, 5, divide by 2, divide by 2. So c is equal to 5 over 2. And similarly for this side, minus 5, 2c is equal to negative 5, divide by 2, divide by 2. So c is equal to negative 5 over 2. And there are my two answers as we would predict for a quadratic equation. Reviewing what we just did on the whiteboard, we set 4c squared equal to 25 in standard form. So once we put it in standard form, then we were able to factor using the idea of the difference of two squares. We set each of these factors equal to 0 and found that c is equal to negative 5 over 2, or c is equal to 5 over 2. Remember, both these solutions will solve the equation. In example number 5, we're asked to solve x squared minus 27 is equal to 6x. So let us go over to the whiteboard and work this out. In example number 5, we're given x squared minus 27 is equal to 6x. Now notice it is not in standard form. Recall that it must be in standard form, and recall that standard form is ax squared plus or minus bx plus or minus c is equal to 0. So how do we get this in standard form? Well, we have to bring the 6x over to the other side and make this equation x squared minus 6x minus 27 is equal to 0. Now, however you want to factor this, we could factor this, and we factor this as x minus 9 x plus 3 is equal to 0. And as usual, we set each of these factors equal to 0, and then solve accordingly. And that becomes our answer would be x would be 9, or x should be negative 3. And of course, we can plug it back into the equation and check to see if that is correct. Reviewing what we just did on the whiteboard, in this example, you must set the equation equal to 0 before factoring. Then set the individual factors equal to 0 and solve. So here is what we did. We have this is our original equation. We brought 6x over in order to get this quadratic equation. Then we factored, and each factor we set equal to 0, and solved each factor and found that x is equal to 9 or x is equal to negative 3. The solution set of this is negative 3 9. And notice how we use the curly brackets to indicate that it is the set of numbers that solves this equation. In example 6, we're asked to solve 2x squared plus 8x is equal to 0. So let us go over to the whiteboard and work this out in detail. In example number 6, we have 2x squared plus 8x is equal to 0. Now, at first you may think, well, could that be the difference of two squares? Well, actually it isn't the difference of two squares, but what we can do is we can actually factor out the x and factor out the 2. So we end up getting 2x plus 4 is equal to 0. And indeed, we have two factors. We have 2x is equal to 0, and we have x plus 4 is equal to 0. Well, if we divide by 2 and divide by 2, of course, 0 over anything is just 0. So one of our x's is actually 0. And then this one, minus 4, and we add that 0 plus minus 4 is just minus 4. So it turns out that in this case, we have two answers, and one of the answers happens to be 0. Let us review on the whiteboard what we did in example number 6. This one uses a different technique than the previous one. Really, this is something you should consider at the beginning of every factoring problem. So here we have 2x squared plus 8x is equal to 0. We can factor out 2x and we get 2x times x plus 4 is equal to 0. Remember, we take out the greatest common factor, and in this case, the greatest common factor is 2x. We find that x would be equal to 0 in the first one because 2x, if we divide both sides by 2, we get 0 over 2, which means x will be equal to 0 here. And then, of course, for this one, x will be equal to negative 4, which we solve in the usual algebraic way. In example number 7, we're asked to solve x squared plus x is equal to 12. So let us go over to the whiteboard and work this one out. In example number 7, we have x squared plus x is equal to 12. Now, at first you may think, oh, wow, I can just factor out that x. But no, you can't, because it's not in standard form. In order to, if you want to use that little trick, you have to have it in standard form, and everything must factor out. So we have to put it in standard form. X squared plus x minus 12 is equal to 0. And now it's in standard form, and it turns out the only thing we can really do is factor it in the usual way, and we end up getting x plus 4, x minus 3 is equal to 0, factoring it the usual way, or whatever way you like to factor it. And we end up, each factor we set equal to 0. And then we solve x is equal to negative 4, and because it's a quadratic equation, of course, we end up with two answers. In reviewing what we did on the whiteboard, for example, number 7, remember we have to put the 12 on this side in order to put it in standard form, to set it equal to 0. So here it is in standard form, and then we factor it, and then we take each factor and set them equal to 0, and find that x is equal to negative 4, or x is equal to 3. In example number 8, we're asked to solve d squared minus 5d is equal to 0. So let us go over to the whiteboard and solve this one. In example number 8, we have, so let's look at example number 8. And it turns out we have d squared minus 5d is equal to 0. Well, here we actually do have it in standard form because it's equal to 0 and we have everything equal to 0. So we can use that little trick of just factoring out the d. So I'll factor out the d and I'll get d minus 5 is equal to 0. And then I have the first factor I have is d is equal to 0. Well, that's already done for me now. And then the second factor of d minus 5 is equal to 0. And so d is equal to 5. So here are my two answers. One is 0 and 1 is 5. In reviewing what we just did on the whiteboard in example number 8, we factored out the d, and we got d here, and then the other factor is d minus 5, and we found that d can be equal to 0, and we solved this one algebraically and found that d can also be equal to 5. In example number 9, we're asked to solve 2x squared minus 3 is equal to negative 5x. So let us go over to the whiteboard and work this one out. In number 9, we have the situation where we have 2x squared minus 3 is equal to negative 5x. Now, if you notice, it's not in standard form. So what we have to do is we have to bring the 5x over so we can have it in standard form. And that means we have to have 2x squared plus 5x minus 3 is equal to 0. And now we have it in standard form, plus or minus bx plus or minus c is equal to 0. And of course, we could factor it, but it's not as easy to factor because our coefficient is not 1. Now, some people can factor no matter what the leading coefficient is, but I'm not so good at that, so I'm going to resort to the method I taught earlier called the AC method. And the A is from here and the C is from here. So if I multiply 2 times negative 3, I get negative 6. And what I want to do now is find an m times an n, where I get negative 6. But if I add the m plus the n, I'll get the middle b, and I'll get positive 5. Well, it turns out that if I multiply 5 times negative 1, I get 6 times negative 1, I get negative 6. But if I add 6 minus 1, I'll get 5. So it turns out that I can break the b into 2 parts, so I can get 2x squared plus 6x minus x minus 3 is equal to 0. Notice how all I'm doing is rewriting the middle term. I'm actually working out factoring backwards. I'm rewriting the middle term this way. So doing this, I can now factor by grouping. So I end up with 2x squared plus 6x, and then I have minus 3x minus 3 equals 0. So I'll look at this one, and I'll look at this group, And then here I will factor out 2x, and I'm left with x plus 3. And here I'll factor out -1, and I'm left with x plus 3. And then I will take this factoring by grouping. 2x minus 1 is equal to 0. And of course, if you don't like this way of factoring, you can factor it any way you like, but I like to do it this way. So now I'm going to take my two terms, and I have x plus 3 is equal to 0, and I have 2x minus 1 is equal to 0. And then I subtract 3, and then I get x is equal to -3. And here I get x is equal to 1 over 2. And again, fractions do happen, so don't be afraid if you get fractions in your answer, because fractions do happen. In reviewing what we did on the whiteboard, we rewrote this example in proper form. Notice that the leading coefficient is not 1. So we use an appropriate factoring technique like the AC method to factor this particular problem. Then we solve as we have done before. You could use any factoring method you like, but I chose to use the AC method. Here is our equation in standard form. We factor 2x minus 1 times x plus 3 equals 0. We set each of these factors equal to 0, and we solve them independently to get x is equal to 1/2 or x is equal to -3. For the AC method, AC is equal to -6. That's multiplying 2 times -3. MN is 6 times -1, and that's -6. M plus n is equal to 6 minus 1, which is equal to 5, which is our B here. You then use this information to factor by grouping and set each factor equal to 0 to get, again, x is equal to 1/2 or x is equal to -3. Thank you. I hope that you enjoyed this video. Be well, take care, and goodbye for now.